Yeah, okay, let's try something else. This synthetic PPG waveform visualizer. Do a short overview of the page.
Welcome back to the deep dive. Sometimes you look at your fitness tracker, see those numbers, heart rate, SpO2, and you kind of wonder what's really going on inside. It feels a bit abstract, doesn't it? So today we're going to unpack something called PulseVision. It's this web application designed to take those abstract signals, specifically photoplethysmogram or PPG waveforms, and make them visual.
Yeah, and the sources we looked at give a really good sense of what pulse vision is. It's very interactive, and they even hint at some pretty interesting future developments.
Exactly. It's a neat way technology can make complex body stuff, well, easier to grasp.
Definitely more accessible.
Our mission today, then, is to see how this tool lets you actually see how different health things change this key signal. It's like a shortcut to understanding those vital signs better. So, okay, let's just jump right in. What is pulse vision, fundamentally, and why is it helpful?
Well, at its heart, pulse vision is about visualizing synthetic PPG signals. These are the kinds of signals used everywhere now to track things like heart rate and blood oxygen. What makes pulse vision neat is how interactive it is. It's really built for learning. You can tweak things and see the signal change instantly.
Right, that interactive part sounds key. So you're not just seeing a static picture, you can actually, play with it.
Exactly. You're experimenting, not just observing. There are these sliders you see. For example, the heart rate slider BPM, beats per minute. You slide it up, the waves on the screen get closer together, faster. Slide it down, they spread out slower. You literally see the heart rate change.
Okay, that makes sense. What about other things like oxygen levels?
Yep, there's an oxygen saturation slider too. This one changes the amplitude, basically, the height of the waveform. So higher oxygen might show up as a taller, stronger looking pulse wave. Lower oxygen, the wave gets smaller, less pronounced. It gives you a visual feel for it.
And I remember reading about other controls too, something about sharpness and the Dicrotic Notch. What's that?
Good catch. Yeah, the dicrotic notch is that little secondary bump you often see after the main peak in the waveform. Its shape, its prominence, can tell you things about, say, how stiff or flexible your arteries might be. Pulse vision lets you adjust how noticeable that notch is. And you're right, there's more. You can change the overall waveform sharpness, make the peaks pointy or rounded. Plus, you can add noise level. This makes the signal look messier, more irregular, kind of like what you'd get from a sensor in, a less than perfect real world situation.
I see. So it's not just numbers becoming a picture. It's about getting a feel for how all these things connect dynamically, like how one change affects the whole signal.
That's exactly it. It helps build intuition. You see how even a small tweak ripples through visually. It connects the dots in a way numbers alone might not.
Okay, that makes a lot of sense for learning. So given what it can do now, what's next? The sources mentioned some potential future stuff.
Oh, yeah, the future possibilities are quite exciting. They talked about adding more controls. Imagine sliders for maybe respiratory rate, or even trying to simulate aspects of blood pressure visually.
Wow, that would make it even more comprehensive.
Definitely. And another big idea is simulating problems, like abnormalities. Think about being able to show what an arrhythmia looks like on the waveform, or having presets for conditions like tachycardia, that's a fast heart rate, or bradycardia, a slow one, or even hypoxia, low oxygen.
That sounds incredibly useful for, say, students or healthcare trainees.
Absolutely. And for the data geeks, there's talk of maybe calculating metrics like heart rate variability, HRV, right there in the tool. Plus, the idea of being able to save or export the waveforms you generate. That opens up possibilities for people to track things over time, share data, maybe even use it for personal projects or research.
So wrapping this up, what's the big takeaway here? It feels like tools like pulse vision are really shifting how we can understand our bodies.
I think so. They make complex data feel more tangible, understandable. It moves us beyond just seeing numbers to actually visualizing what's happening inside.
Brings clarity, right?
Exactly. And it raises a really interesting question for everyone listening. How could tools like this, these interactive visualizations, change how you look at your own health data? Could it help you move past just tracking numbers to gaining, real insight, deeper understanding?
Something to think about, the power of seeing your body's signals come alive. We hope this deep dive sparked some thoughts. Join us next time for another exploration.
Okay, so that was obviously Notebook LM. don't think I can do any better. Well, unless another human joins in or something. If you have any questions, yes, there is a human in the loop. Otherwise, we'll keep using the robots. So what shall we jump into next? Or should we do some development?